Hello everyone, welcome to my channel. Today we are going to take a deep dive into Linux architecture. I am Anil Gungde and today I will be explaining the Linux operating system, a system known for its efficiency, robustness and the open source nature. We'll explore how the core components like the kernel, system libraries, hardware layer, system shell and utility programs work together to make Linux such a powerful OS. So let's start with a quick overview. Linux is a popular open source operating system used globally in everything from web servers to mobile phones. At its core, the Linux architecture is structured into multiple layers, each serving a unique function. This architecture is designed to maximize both flexibility and security. Here we have five primary components in the Linux architecture: the kernel, system libraries, hardware layer, shell, and system utility programs. Let's start with kernel, the most essential part of any operating system. Think of the kernel as the brain of the OS. It manages hardware resources like the CPU and memory and controls communication between hardware and software. Every time you open a program, the kernel allocates memory and handles tasks to make sure that programs don't interfere with each other. There are different types of kernels, each with unique properties. For instance, monolithic kernel contains all essential operating system services in one large block, making it fast but harder to modify. Microkernel only includes the minimum functions necessary like communication between processes. This makes it easier to expand and but can be slower. Exor, exokernel hybrid kernels are other variations that combine elements to improve efficiency or add flexibility. The Linux kernel itself is a modular, meaning part can loaded or unloaded dynamically, giving it great versatility and across different systems. This flexibility is why Linux is used not just on PCs but in embedded systems, servers and even mobile devices like Android. Next, we have system libraries. These libraries are essential because they allow application to access kernel functions. Think of as a translator. While the kernel controls low-level functions, most applications can't talk to it directly. So system libraries act as a middleman handling system calls between applications and the kernel. For example, the GNU C library is a widely used systems like library that allows programs to use kernel features without needing to be rewritten. An important concept here is the idea of shared libraries. Unlike static libraries, shared libraries load at runtime and can be used by multiple programs, which saves memory and improves system efficiency. Many applications can share the same code while keeping their process separate. This modularity is a core principle in Linux, contributing to its stability and efficiency. System utility programs provide specialized functionalities enhancing the core operating system. These utilities perform runtime tasks like the file management, security and backups. Imagine you need to backup your data or perform a virus scan. Systems utilities are designed for such jobs. They include tools for things like file management to organize, move and manage files, disk management to repair or optimize storage devices, network utilities to monitor or troubleshoot network connections. With these utilities, Linux gives users powerful tools to maintain and secure their systems. Many of these utilities are command line based, which allows for more precise and control. It's common for Linux administrators to use commands like top to monitor systems performance or resync for backups task, which makes these utilities incredibly versatile. Hardware layer is where the physical component of the computer like memory, CPU, and input output devices interact with the operating system. This is the foundation on which all operations take place. Linux hardware layer manages input and output devices such as keyboards, mice, and graphics and cards and network interfaces. In the Linux hardware layer is abstracted to ensure the OS can work with various hardware types without needing major changes. For example, a Linux distribution can run on anything from a small Raspberry Pi to large data servers because of this hardware abstraction when we talk about the CPU or RAM. This layer makes sure that each application gets the resources it needs, handling requested and efficiently and ensuring that no single program can monopolize and resources unless given permission. Now let's discuss the shell, which is the interface that allows users to communicate with the kernel. The shell takes command from the user and interprets them for the OS. You can think of the shell as a translator between the user and the kernel. There are two main types of shells: command line shells and graphical line shells. So, command line shells like a bash or a sesh, which require users to type commands. This offers high control and flexibility, making it popular among developers and system administrators. Graphical shells provide a visual interface allowing users to interact through icons and windows. Different shells are optimized for various tasks. The Bourne shell was one of the first shell, while the Bash shell, Born Again shell, is now one of the most widely used shell on Linux Advanced. User can even write shell scripts to automate tasks, which can be huge time saver for repetitive tasks. To sum up, Linux architecture is built on a layered approach that separates each functional area. This modular design provides flexibility, efficiency, and stability. Understanding Linux architecture reveals why it's such as a powerful OS and why it's favored for both personal and professional environments, for desktop to servers. Thanks for watching. If you enjoyed this breakdown of Linux architecture,